I want to tell about JSON Web Token authentication and authorization features in EMQX. What is a JSON Web Token? We have some complicated definition of JSON Web Tokens. They are objects, pieces of data that are moved around the web that carries some important information, and this information is stored in so-called claims. JSON Web Tokens can be encrypted or can be signed, but in practice the things are not so complicated often. The very definition of JSON Web Tokens is contained in an RFC document. The mentioned claims, the pieces of data carried in JSON Web Tokens are usually simply fields in some JSON objects. And generally, JSON Web Tokens are signed and not encrypted. Let's see the structure of JSON Web Tokens in more detail. They consist of three parts. The first part is the header, which contains some important information about how the JSON token is signed. The header contains the algorithm, the signature algorithm. Then comes the payload. It's the core of the JSON token. It holds the mentioned claims. That means just some fields. Some fields are predefined, such as expiration time, and also any custom fields can be added to the payload. Both header and payload are base 64 encoded, and the last part is the signature. The signature is signed with a secret or with some private key, and it is also base 64 encoded. The three parts are concatenated with a period. This makes JSON Web Tokens quite compact and overall safe. Now let's see how JSON Web Tokens are used for authentication. The algorithm is the following. A client has its own credentials, maybe username and password, and client exchanges its password, its credentials to a JSON token. A JSON Web Token is given by an authentication server. Generally, it is a standalone server like, Keycloak or Alt0. There are a lot of them. Then, having a JSON Web Token, a client connects to EMQX and carries this token as some MQTT connect packet field. Generally, this is password field, and EMQX verifies the token signature, and if it is correct, the client is authenticated successfully. What are the advantages of JSON Web Token authentication? First, JSON Web Token is an internet standard, and there are a lot of authentication services that provide JSON Web Token exchange, and these services are often a part of a user infrastructure. Also, JSON Web Tokens are small and they are easy to manipulate with. Also, one of the most important things that JSON token authorization decouples credential storage from EMQX. the credentials are stored securely in some standalone third-party authentication server, and EMQX doesn't know anything about the credentials. It just can validate the JSON token with keys or some secret. That also makes JSON Web Token authentication very lightweight, because EMQX doesn't have to access any external resources when authenticating a client. Also, JSON Web Token authentication has some caveats. That is, JSON Web Tokens are not encrypted. They are signed. That means that JSON Web Tokens just cannot be forged by a client, but they may be stolen. And after that, a malicious user can use these tokens until they expire. So first, JSON Web Token lifetimes should be chosen correctly, so that there are no long-living JSON Web Tokens. Also, the use of secure connections is strongly recommended. Also, if HMAC signatures are used, the secret should be kept on both sides, on the side of the authentication server and on the side of the EMQX. So EMQX should be somehow provisioned very securely to avoid this secret leakage, because then a malicious user can forge JSON tokens. Now let's see how the things look in practice. Let me share another screen. Okay. Now let's try authenticate with some JSON tokens first. We should run a toy authorization server, which will sign our JSON tokens, and to which we will access to exchange our credentials. Now let's configure EMQX. Let's make a brand new copy of EMQX. Now let's enable JSON token authorization plugin. Now let's forbid anonymous access. And finally, let us configure the very JSON Web Token plugin. Here we have a secret, HMAC secret, which is shared between EMQX and authorization server. Also, we enable claim verify, and we verify user's username. That's all. Let's try to start EMQX. Okay. Now let us contact our toy authentication server, pass username and password, the credentials, and obtain. Sorry, it's not kind of token. Let's obtain a HMAC token. Yes, here it is. We received the token from the authentication server. It is signed with HMAC algorithm, and it contains our username. This username is verified by the EMQX. We can't substitute any other username here because the whole JSON Web Token is signed. Now let's try to access the EMQX with our token. Let's try to subscribe some topic with the username and with the obtained token. Yes, we succeed. And now let's try to use another username. Yes, we failed because EMQX verifies that the username coincides with the username signed by the token. Now let us configure EMQX to be a little more secure. Let us disable HMAC authentication, and let us set up fetching of public keys from a JSON Web key set server. Just a moment. Okay. And let us set timeout to 10 seconds just to see things. Okay. Now let's start the EMQX again. Let's see that now our EMQX fetches regularly keys from our toy authentication service. Let's see how the keys look. Well, our toy authentication server provides some keys. The keys have their IDs, and they are public keys, and they should, of course, fetched by HTTPS in production. And this is a secure way to encrypt tokens because EMQX doesn't have to store any secret data. It just fetches public keys, which are public, and the authentication server encrypts JSON tokens with private keys. Let's see how that looks. Well, we access the RSA endpoint. The token is now signed with the RSA algorithm. And also in the metadata, we have key identifier. Let's try to do the same. Let's try to access the EMQX server. Yes, we succeed. And if we try to use another username, we fail. Now, this is a more secure way to assign JSON tokens, but this requires some occasional contacts between EMQX and the authentication server, but the keys can be cached. So this usually is not an issue. Now let's demonstrate authorization with JSON tokens. Let's reconfigure EMQX once more. Let's forbid all topic access by default. We also remove all ACL rules, permissive. And see configuration parameters for JSON token authorization. The authorization data will be packed in JSON tokens, and we have an option to specify the name of the claim where all ACL lists will be packed. Now let's restart our fix again. And let's obtain a JSON token, which sorry. Yes. Our ACL tokens are HMAC encoded, so we should return back our HMAC settings. Yes, here we see that the token contains not only username, but also some ACL rules. These ACL rules are topic whitelists, and here we specify that the client that provides this token is authorized to subscribe to the listed topic. Here we have just one for simplicity. Now let's try to subscribe to the topic. Yes, we succeed. Now let's try. Well, that should not work. We check that, and let us try to subscribe to some other topic, and we fail again because the topic that we tried to subscribe to is not listed in the ACL rules. ACL rules can improve performance greatly because EMQX also doesn't have to access any external resources to fetch topics, and they are just contained in the data associated with the client, and this data is fetched on the authorization stage. And so JSON Web Token authentication and authorization are very lightweight, and they reduce load on the EMQX greatly. That's all. Let me go to the slides. Thank you. That's all.
Thank you. Does anyone have any questions? No. It's clear. Could you stop recording?
Yes.
It's at the bottom of the screen.